Understanding search algorithms.
What search algorithms help you find data efficiently? Common types include linear search, binary search, hash-based search, and tree-based search. Each has unique strengths and ideal use cases. Choosing the right one depends on your project's data structure, dataset size, and performance requirements. Let's explore how to match a search algorithm to your needs for optimal results.
Start with your data structure.
Your choice depends on how your data is organized. Linear search works well on unsorted lists or arrays. Binary search requires data to be sorted, often in arrays or similar structures. If your data is stored in hash tables, hash-based search is the go-to option, while tree searches are ideal for hierarchical or sorted tree structures.
Consider data size and efficiency.
For small datasets, linear search may be sufficient and easy to implement. As data grows, efficiency matters more. Binary search dramatically improves speed on large, sorted datasets. Hash-based and tree-based searches offer faster lookup times for massive or dynamically changing datasets. Assess dataset size to balance simplicity and performance.
Analyze performance needs.
Do you need lightning-fast lookups, frequent updates, or both? Hash-based searches excel at speed, but may be less flexible for updates. Tree-based algorithms, like binary search trees or AVL trees, handle frequent inserts, deletes, and range queries more gracefully. Know your project's priorities to select the most suitable search approach.
Think about maintenance and scalability.
Some search algorithms are easier to maintain or scale than others. Linear and binary search are simple to implement and debug. Tree and hash-based searches can involve more complex code but scale better as data grows. Consider your team's skills and future project needs when making your final decision.
Bringing it all together.
Choose a search algorithm by reviewing data structure, dataset size, performance needs, and long-term maintenance. Test different options if you're unsure. Profiling actual use cases helps ensure you make the best choice. The right search method saves resources, boosts speed, and keeps your software efficient and future-ready.